So we're now going to discuss the chain rule a little bit. So first of all, what does the chain rule say? It says that if I differentiate this composition, I get first the derivative of f evaluated at g of x, and then the derivative of g evaluated at x. So here it's important to notice that by this, I'm taking the derivative of f first, whatever that is, then plugging in g. And here I'm first plugging in g and then taking the derivative. So I'm doing these operations in opposite order. Now this notation is quite bad. So this is why the Leibniz notation is often used, and it's often also useful to give different names for the variables of f and g. So usually you could say g lives on the x-axis, f lives on the u-axis, and f gives values in the y-axis. Why not? Then g sends its values up here, and then f sends its values like this. Okay. So if you here, well, let's just call this point x. So then here you would get g of x, and here f would send this to f g of x like this. So we can write this as y being f of u and u being g of x. So this is what I would call the inner function. This is the outer function. And likewise, this is what I call the outer derivative, evaluated at u equals to g of x. And this is the inner derivative at x. So f of u is outer derivative, and g of x prime is the inner derivative. And here it's useful to say that, well, this is the derivative of u with respect to x, and this is the derivative of y with respect to u. Or if you want, you could just simply say this is the derivative of f with respect to u, and this is the derivative of g with respect to x. So there are several ways to use this notation. So if I want to express the chain rule using these things here, I could say that, well, here I'm taking the derivative with respect to x of f of u. So when I write u here and I write the x here, I'm kind of signaling that, okay, u in some way depends on x, and we need to figure out that dependency to compute this, which is more or less what's written here if I would just replace this by u. And then how to express this part? Well, here I would first have the derivative of f with respect to u. So this is the outer derivative. And then evaluate him at g of x, which I can write like this, or sometimes people prefer to do this thing here. And then what do I have here? Well, here it's not so weird. Here I just have the derivative of g at x, like this. So in this notation here, you're signaling clearly that I differentiate f with respect to his variable, then I plug in this. And here I differentiate g with respect to x, and then I just keep the x. Here I differentiate f, which is a function of u, but with respect to something that u depends on. This is what this means. So let's look at an example to illustrate all of this. So let's try to differentiate sine of x to the third. Now this would be my outer function, and this would be my inner function. So if my outer function is now f of u equals to sine u, then my outer derivative is just this. And who's my inner function? That's x to the third. Then my inner derivative is this. So now if I use the chain rule, I first write the outer derivative, cos u, evaluated at g of x. So that's cosine u evaluated at x to the third. And then I multiply by the inner derivative, which is 3x squared. And then I'm done. So if you feel as if this is difficult, then I think a good help is to write out explicitly who are the inner and outer guys, and then plug things in carefully.